alaikum. Hello everyone. We have the pleasure to participate in the 8th International Renewable and Sustainable Energy Conference with this video titled Optimizing the Depth of Junction of Solar Cell Junction, Silicium and Heterojunction Al-Gas GIS Comparative Study, prepared by Dr. Aysani Hussein, a doctor in the Higher Normal School of Bashar, Algeria. The aim of this work is first to optimize the junction depth of homojunction silicium and heterojunction Al-Gas GIS solar cell before entering performances of these cells such as density current, spectral response, conversion efficiency. Problematic is how to optimize the depth of the two structures of the solar cells, the first homojunction silicium and the second heterojunction Al-Gas GIS, to improve the performance of these structures such as the current photo, open circuit voltage, form factor, spectral response, and photovoltaic conversion efficiency. For the theoretical model, we present the theoretical model, GGLU model, which describes the operation of homojunction silicium and heterojunction Al-Gas GIS solar cells in the case of cell elimination and darkness. The GGLU model is based on solving the continuity equation. So we discuss our results. For the cell in silicium, the simulation of the performance of the cell silicium allows us to obtain the following results. We know in figure 1, we know that the power delivered by the cell silicium structure increases as function of the depth to a thickness of the order of 0.1 micron, while undergoes a remarkable degradation. In the figure number 2, we know that the spectral response takes its maximum values in the wavelength range 0.45–0.85 micrometer. In figure 3, the first remark that the yield of this cell does not exceed 20% for all the values of Xg, and it is also noted that this yield takes its maximum values in the range 0.1–0.9 micrometer. The second remark is that the form factor is practically constant for all different Xg values. It gives more than 80% for Xg between 0.1–0.9 micrometer. So we can deduce that the optimal depth of a silicium cell varies in the range 0.1–0.9 micrometer. For the Al-Gas GIS cells, the simulation of the performance of the Al-Gas GIS cell allows us to obtain the following results. In figure number 4, we note that the VCO is practically constant for the different values of the depth Xg, whereas the current GCC is variable. It takes the maximum in the interval 0.2–0.4 micrometer for Xg. In figure number 5, we know that the spectral response provides a better value in the range where the wavelength lambda varies between 0.2–0.39 micrometer. So figure number 6 shows that variation of the parameters of the Al-Gas GIS cells as a function of the depth. We know that the performance takes its maximum values for depth vary between 0.2–0.4 micrometer. The optimal depth of an Al-Gas GIS cells is of the order of 0.2–0.4 micrometer. As a conclusion, we can say that the depth of the junction of a solar cell Xg is an important parameter. If Xg is large, the front is preferred, not that fewer photons arrives in the base. For this, the absorption coefficient increases slowly with the energy of photons, which therefore penetrate deeply into the silicium structures. So it favors the base. In the case of the Algagia structures, the front layer must be thin enough not to absorb the light too much because of the crystalline parameters of the two materials, which must not be different. It is therefore necessary to use excessively low values of Xg in the order of 0.2 0.4 micrometer. Thank you for your attention and Assalamu alaikum.